Okay, so here's a quick introduction to XP, or Extreme Programming, which of course we're going to talk a bit about why even bother with this stuff and how agile methods come about, and then talk about why XP will be probably good for your team, but also some sort of lessons about why it might not be so great as well, okay, to be sort of honest about that. So, how does this all come about? Well, you guys should know all about this from, the sort of software crisis of the 1960s or thereabouts, where software was, delivered, it was way too expensive and the scope didn't match. It really sucked quality-wise and the clients were really upset. Pretty much like now. Just you do it faster now, but they still don't like it. Okay. And you can see that if you sort of traverse sort of history from there, you can see that the waterfall model and things like it were sort of like a direct sort of knee-jerk response to that sort of software crisis to say, you have no control of your process, so we need control. Therefore, you need to block things up and do things in these sort of, waterfall-like phases, like requirements, design, programming, testing, maintenance, that sort of stuff, right? And then what happened was that, and that came about because people who were not software engineers said that that's how we do things, that's how you should do stuff, because you're supposed to be engineers. Because again, if you look at a civil engineering project, if you look at that building at the back of building 18 and 23 there, you'd say, I've no clue what they're doing, just a bunch of people in hard hats and high vis, right? But they're pouring concrete for a good reason, I imagine, because it's costing a lot of money. But you can see things happening. Whereas what do people see when they see you people do stuff? What are you doing? Facebooking or something? They can't tell what you're doing. So it's a bit more difficult to apply more conventional engineering practices to software engineering, perhaps, in some respects. Not completely, but in some respects. Anyway, and then, of course, eventually someone worked out a decade later that you guys built things, but it wasn't great because you never talked to your customer until long after it was actually necessary to do so. So that brought yet another race around the track and another knee-jerk reaction, which brought about the advent of prototyping and cycling methods, that sort of iterative methods and things like that. And that was seen to be a good thing because you actually had to talk to your customer and get feedback from them about how things were going. And you would have seen those sorts of models where you sort of, show the customer something, change the program based on the feedback, and you iterate around and again until when? It's a circle, right? And a circle has no end. Well, it does, because eventually the customer says, I've got to do some work now, please go away. Or what happens is they run out of money, in which case you go away. So that's sort of true. I guess it's probably the biggest failure of prototyping, I would think, is that it's not so much about running out of money. It's more that it doesn't recognise where the hard work is. So that when you show a client a prototype, it's not actually working, it's just a prototype, so it's a sort of a kludged up version where you've fed it some data to make it look like it's actually going, but it's not actually necessarily working software. But the client looks at that and says, oh great, you've built it, we're good to go. And you have to try and tell them, no, it's not quite working yet. What you're seeing is the front end stuff, which is pretty easy to do, and you haven't actually done the back end stuff, which is generally the harder stuff to solve from a software engineering point of view. So that means that you've got a lot more work to do, but they don't know that. Hard to convince them of that. So that's a bit of a failure of prototyping, perhaps. Anyway, so moving on yet another 10 years, and that led to a sort of the rise of object orientation. How can I get objects? Objects solve everything, right? So you're all great programmers, you know it backwards. Yeah, no, you don't have to be, it's okay. Objects basically failed too because of, had, again, a great idea, but what can I say? The people who do it really well, and the rest of the people say, what on earth does that look like? Why is it like that? So object orientation itself didn't really deliver either, which led to a sort of a rise in design patterns. And design patterns are interesting because they didn't really come from a sort of theory of computing like objects did. They came from people's experiences. So you look at the Gang of Four, they basically said, we all seem to solve these problems kind of the same way. If we had some common language describing those things, we could pass that knowledge on to someone else. What a good idea. Hence the Gang of Four and design patterns. So if you can read a class diagram, you can read a design pattern. And the whole point about using class diagrams was so that you could actually transfer that knowledge from language to language independent of any said language, sort of. And that sort of led to the rise of, I guess, service-oriented architectures and more sort of compartmentalization and sort of multi-layer architectures and that sort of stuff. But, well, we're still not there yet because, again, at the same time, in terms of ways of building things or methods, there was a bit of a knee-jerk reaction against more conventional methods that relied a lot on making sure you've got the process model right or the data model or whatever, because a lot of those methods relied on that customers signing off on stuff they had no clue about. And so it became a bit of a game where you try and push stuff to a client and say, you have to sign this, otherwise you're holding up the project. And I'll say, I don't know what that is, which is a bit unfair, really. So method was used as a way to, as a leverage for something else in a project. I think that's not true. It's been quite well documented, you know, so I could show you those articles if you want, but it's quite, but people actually, different parties use methods for all sorts of reasons, not a lot of which was to do with actually building software. So, anyway, and that was a bit of a knee-jerk reaction against that, saying, well, these methods are kind of not particularly customer-centered, despite the fact they say they are, and they really don't necessarily deliver software, which is the point. So therefore, it was seen at the time that we needed some sort of more lightweight, or now remarketed, agile methods to build software. And hence the rise of Scrum and DSDM and the ones I've mentioned here. So, and again, with any method, no matter which one it is, you will find that it's always got a poster child project that says, this is why it works. And it's usually some big high-profile thing. Okay, so it doesn't matter what it is, there's always at least one project that says, this is why you should do this, because, you know, some other company used this to do this great system and it works. So, for extreme programming, it's actually the C3 system at Chrysler that is the poster child project. And it's, you know, whenever someone says, you know, oh, you can't use XP for big projects, they would point at that one and say, oh, but you can, because Chrysler used it to build this big payroll system. So, at your leisure, have a squiz at the blog post about that, about what they really thought about why it worked or didn't work. It's kind of interesting. But it doesn't matter which one you pick, there's always some project that says this is the one why it says it works. Because, I mean, that's the way that game seems to be played, is that people say, I've got a new method for building stuff, it's better than everybody else's. How do I prove that? I prove it by having a client team that's motivated and we produce some great software, therefore ours is better than theirs. It's symptomatic of a discipline that's relatively new. I mean, the term software engineering wasn't invented till, what, 1969 or something. So it's a relatively new discipline. Especially, you might say, well, not really. It's been around a while, but not compared to aviation, not as you like in terms of aeronautical engineering, and certainly not compared to civil engineering, building roads and bridges and buildings and things. We're doing that stuff for thousands of years, right? Building the roads and things. So we probably know how to do that. Well, they do, right? They have a standard way of doing it and it works, right? But it's not quite the same in software yet, okay? We'll get there eventually, but we're not there yet. So, you know, my point is having lots of methods that may or may not work for a time and having things go in and out of sort of favour as to what's the best method to use is fairly symptomatic of where we are. There's nothing really wrong with that. It's probably reasonable for that. That's what we should be, probably. You know, I'm sure in the far future, your children's children's children will be using the iPad 3000 to just say, I want to build an app. Do it for me. I'm thinking of this. Go do it. Or whatever. I don't know. Something will happen, but it won't be, whatever it is, it won't be this. Because as we said last week, if we could predict the future, we would have bought choice using Apple 12 years ago. Anyway, so check out the link. It's quite interesting. There's a range of off-links to that to sort of talk a bit about why it's still used for some of the group and why it didn't work in other places and why it had a problem at Chrysler once they got it going. Interesting that, I mean, I think I mentioned last week that, you know, the top 3 causes of project failure are either lack of understanding of requirements, lack of user involvement, or lack of management support. Number 3 for the C3 project. But you'll read what they talk about. They had a shift in management and that meant that they had some issues about what the project was actually doing. Okay, extreme programming itself. Oh yeah, it's an agile process, because they all are, right? So suddenly you need 2 to 10 developers in 6 months? No, you don't. I mean, that's what they thought when they first built it, okay? So they said, oh, this is kind of smallish sorts of projects. So you've got 4 developers, that's good. And a duration of, 1 to 6 months, well, a couple of months. That probably fits. It's got core values and principles and practices, like any other method that you pick, whether that's sort of an old school one or an agile one, doesn't actually matter. So I think actually there are 5 values now, but that's okay. We'll stick with the 4. Communication is kind of important. They do that internally via the pair programming thing, and by usually having an on-site customer is a sort of a thing you're supposed to do with extreme programming. In practice, that doesn't necessarily work as well as they say it does, because the customers that have the knowledge are the ones that have most value to the business. Therefore, they're busy doing business because that's where they have the most value, as I just said. So the customer rep you get isn't necessarily the one you want. So having an on-site customer is cute, but not necessarily going to be the best value for you. In your case, you'll have 4 on-site customers of sorts, and they'll be really keen to get a good mark too. So that'll be good for you guys. Simplicity is interesting. You'll see when we see in a minute, when we talk about test-driven development, the idea is that you, as we said, you look at the requirements, build a test that tests the requirement, and build the smallest bit of code you can that meets that test, that makes the test pass. Therefore, you have then met the requirement, and therefore building the simplest bit of code you can. Then the trick is you're supposed to go back and refactor that and fix it. We'll see how that goes. Feedback's all about testing. Well, yeah, that's the unit testing cycle. Courage is kind of interesting. You can't tell me that people that don't use XP don't have courage in a build or an app development. Of course they do. That's hardly unique to extreme programming. Then again, I suppose courage is when you do something that breaks the build and you have to fix it, because whatever you've done is just messed things up. Anyway, more about that in a minute. Okay, so the practices. You're not necessarily have to do all of them, but there are some you are going to do. Okay, so small releases will actually show you that actually suits what you're doing because of the scope you've got. Planning game kind of works for you because I think last week I mentioned the important thing for you to do was, having captured the requirements in whatever form, you need to make sure that as you do things that your client still wants them done in that order. So for you, going back to the customer and saying, so now we've done number 1, is number 2 still number 2? It's going to be a really, really important thing for you to do. So that's what we meant by jointly plan. You're not asking your clients to plan unit tests. They don't know anything about that stuff. Okay, that's not what I meant. Simple design. Well, yeah, that's why I have a bit of a different opinion about me and extreme programming, about whether this is a good thing or not. Complexity makes things difficult to understand. No, complexity is there because it's a complex problem. Therefore, wants a complex solution. You don't mix simple and simple and complex and complex. You don't cross things over. It's a bad idea. So I don't always agree with this. Unit testing is a good thing, though. So unit testing is what we don't know about yet. We're going to find out about. Acceptance testing is what we probably call black box testing in a software engineering sense. And refactoring, improving it. Yeah, when you've got lots of time to do that. But when it works, if it works fast enough, why are you refactoring? Why change anything? Well, I guess you'll find out as you get through this whether you need to do that or not. What else? Pair programming. You will be doing that because, again, there's 4 of you, 2 pairs. And again, you might cross it over. You might say, well, this week it's pair 1 and pair 2, but the next week we're crossing that over. There's nothing wrong with doing that, by the way. Nothing welds you to the person that you're paired with except that session for that day, if you want, or that work session, okay? That's kind of interesting. Well, we'll see how that goes. Collective ownership. Yeah, because you've got you've got a build and you've got a build tool and a config management tool. That's a config management tool. Then you're able to have people change things. Oh, gee. You should let go a little bit. That'd be interesting. However, make sure there's backups. I keep backups. I'll definitely do that. The integration business. Well, that means you're able to actually run a build and see if whatever you've just done is broken it. So if you know if the build worked before you started and now it doesn't work, you did it. Okay. And if that motivates you to do small things that work, it's probably a good thing. That's what the XP guys recommend, actually. Let's see what else. I'll talk about think of something else in terms of coding standards in a sec. 40-hour week. Yeah, well, it doesn't be 40 hours, guys. But that's what they said. They were basically saying overtime doesn't help you. It's better. So rather than having a 90-hour debugging session, it's better to build small things that actually work. And that is, I guess, the point about extreme. The thing I do like about it is when you look at a requirement, you build whatever it takes to make that actually work. There's no faking it. You actually build the code that makes it work, which is probably not what you used to. No. What else? The on-site customer, I've mentioned them already, so, yes. See how that goes. Now, having standards. Standards are pretty useful, so you have to find a coding standard you're happy with. And I was going to mention something about the integration to do with that, which was that... No, I've lost it. That's okay. I will come back to that. And again, you can find out lots of different coding standards. You can choose one, whatever works for you guys. Okay, but that's so if you switch pairs and swap around, or you cross over pairs, that you can read what someone else has done. So you can get really simple coding standards that actually work, and you get really complex ones that still work but take a fair bit of interpretation. I probably wouldn't choose one of those, if you know the ones I'm speaking of. The reason why you might want version control is you might think that, well, if we've got one pair working on the code, what are the other two doing? If someone's actively working on the code, you don't want to muck around with the build, but you might want to split it and fork it out. You might think, if there is a way to parallelize some parts of the build, you might think about that. It's kind of anti-XP because you're supposed to work on one thing at one requirement at a time, but you might decide in your plan that you want to actually get this done. So you might think about if there's ways to parallelize some parts of it and still be more or less true to the principles of XP but get stuff done, you might need to split and fork the build in some way and then recombine it at the end. Interesting, hey? It's not what you're sort of supposed to do exactly, but I don't see why not. Because again, if you can parallelize parts of the requirements, you might want to think about that. It's more efficient that way. Again, reintegrating that's going to be interesting, but certainly not impossible. So think about that. Okay, there's the cool diagram about the practices, and you can see some parts of those things are really good for you guys. Customers doing some tests on the left-hand side there. So again, how are you going to get them to test it? Hence the black box stuff, okay? You need them to prove to themselves that you did something, okay? And requirements documents don't do that, and neither do unit test documents for them. They do for you because you need to prove that the code actually works to yourselves, okay, internally. But for them, they're going to look at unit tests and say, what's that? Does the thing work or not? And the best way they can do is by testing it, by actually running it themselves. Small releases, definitely part of the good thing, as also is continuous integration and collective ownership. A coding standard, TDD, and paired programming. So, how much of all of those things you get to use. We've specified some particular things we think are probably the things you should definitely focus on. It doesn't mean you can't use all of them if you want to. What else? Do you want to follow this exactly? That they write user stories and then you estimate them and then they choose which stories they will develop. This bit's come out of an extreme programming book, and there's lots of those things. And they're written by the guys that developed extreme programming. That's all great, but then you find out how to actually do it in practice, which could be a bit different. Okay, like I said, do you want them writing the user stories, or do you want to write it with them? That might work better, actually, if you do that. Okay, and then. Are you going to estimate them and then have them choose something? Probably not. I haven't got time for that. Probably you're going to get them to, you're going to write it with them and say, right, we're going to start building this stuff, or we're going to rank it. You guys are going to rank it, we're going to start building it. Off we go. I doubt if you're going to have time for them to choose which stories will be developed, because the apps aren't going to be that complex, I would hope. As for estimation, you've got as long as you've got, the end of the semester. So whether you need a planning game and all the rest of the bits and pieces, what XP is not great at is documenting what's gone on. So it's very code-centric rather than design-centric. And the people that developed it said that's a good thing because they think the code is the thing. Whether that's true or not, you can Google that. There's 1,000,001 Reddit streams about it, threads about all that sort of stuff, about whether that's true or not. And it doesn't matter what your hobby horse is. There'll be someone to say yes and someone else to say you're completely off the planet. That's not right at all. I wouldn't even get involved in that. But it is code-centric. And so what you don't want is writing comments like, I don't know, if the code says I++, you don't want a comment that says add 1 to I. That is perfectly true and completely useless. Don't do that. You're not helping yourselves and you're not helping us either, because we look at that, we just say you're not taking this seriously, are you? So what do people do that actually adds value to an XP project? They do two things that I know about. One is this ranking business. Okay, so you've got a lot of requirements developed somehow with your customer, and you go and build number one. Once you've built number one and they've proven to themselves that you've done it, you then don't start number two straight away. You then go back to them and get their agreement about what's next. Okay, that idea of them ranking the next highest priority requirement is really important. Gets them to buy into the project, and you're always building what they want. So you can't really lose. Okay, but if you do something random that you want to do, then they're going to say, that's cute, but I thought we'd be seeing something else. It really does help if you let them rank them for those reasons I've outlined. It's one thing that people actually, and you won't find this in the XP books, by the way, just so you know that. Okay, that's one thing that people do that actually works. The other thing that people do that works is when they write comments about things that they're doing in the code, they don't write nonsense like I was just describing them. They write about design decisions. Okay, because if someone else has to change what you've done, they don't want to know. They don't want to know the add 1 to I. They want to know why you chose, I don't know, some weird algorithm. Why you chose quad trees for image compression or something. Because they'll say, yeah, but there's so many other ways of image compression. There's lots of other ways of doing it. Why did you choose quad? What was that about? They want to know why you chose something. So why you chose using an algorithm, why you chose a certain connection to a database, why you chose a certain standard for something, okay? Or a conventional way of doing something, or an unconventional way of doing something. Because you know what? The next person looks at it and says, that's strange. Why did you do that? I could do it so much better. They want to know why you did something. So think about your comments in terms of design decisions, and that will actually go a lot further. Okay? A really good thing. You might think, yeah, but it's only across the pairs. It'll still help the other pair when they look at what you've done and say, why did you do it that way? I could refactor that and make it so much better. But should they? Maybe they shouldn't. Maybe there's some underlying reason why you've done something that's not explicit in the code. You explaining that in a comment is a really good thing to do. You will help everybody by doing that. And in a practical sense, you actually help the team who comes after you to do maintenance as well. In a real project you would actually be saying, this is why I did this. It looks a bit weird, but there's a really good reason why I chose to do it this way, and this is what it is. Because of the nature of the data or something else about it you may not be straight across right now. And that really helps other people. That's what it's about. Okay, so how much of this you actually use? Have a think about that. The biggest thing is probably small cycles and then making sure that you've got that TDD in place so you don't break the build. So you do small things that don't break, and then describing what you've actually done in a sort of design sense really does help. Okay. So the takeaways I get from that. Oh, and there's a pretty good looking sort of project plan there, straight out of one of those sorts of things I mentioned. Whether you need all of that, well, I think you need acceptance tests. You need some sort of planning for deciding how you're going to give something to them. You need small releases. And thinking about how you're going to do your iterations in terms of test-driven development is a good thing. The rest of that stuff, have a think about it. Well, it's a typical day. Yay. So you do a pair up and do a quick design session. This is you guys on the whiteboard arguing about something. That's great. So if your customer were watching that, what would they think you were doing? Who knows? But the biggest thing there is the thing you do next is decide what the test is going to be. So you think about the requirement, say, right, can I write a test now that actually tests that or not? And if I can't write a test for it, maybe that requirement's harder than you think. Okay, there's something else going on if you can't write a test for it. Then you do the code, refactor if you can, if you think you need to, if you've got time to do it. And then you basically decide, okay, refactor or not, and then decide if you can integrate this into the build, or actually that was a sucky idea, it didn't work. Not everything you do is going to work necessarily. That's what happens now. You're just less aware of it, perhaps. Unless you really like 90-hour debugging sessions just before something's actually due. Whatever motivates you, really. Oh, not going to, oh, good grief. You can read that later. What's a user story? We should say what they are. Sort of lightweight use cases, that's true. Use to create time instruments. Well, so again, one of the things that I said XP's bad at is actually recording stuff. So more conventional methods are big on capturing requirements and doing big designs and all that sort of thing, which is why I said to you guys in your assignment, think about what other models you might like to use that help you. Okay. So 3 sentences, da-da-da-da-da, and they contain some test, which is useful. So here's a contrived one. So you can see there's sort of like use cases in that way. I mean, and you can see, oh yeah, sort of. I can see that, that looks a bit like a scenario or an interaction in a use case, and the test case is pretty much like a post condition in a use case. And again, if you guys feel strong you want to use use cases in that sort of format you learned about in first year, sure. There are different ways of trying to capture the same thing. What is this thing supposed to actually do? And again, whether you want to use real use cases or essential ones is also sort of up to you. I'd use real ones because you can show that to the actual client and say, when you tap this, this is what is supposed to happen. Have I got that right? You can be very, very concrete with them, and I'd recommend that. Okay, will really help you. Alrighty, so why is this good? It's all about customers, right? And teamwork and communication. It is about continuous measurement, which is a good thing for software engineering. Incremental development is supposed to be a good thing. Simple design, arguable. Frequent redesign and refactoring, you hope so. Frequent extensive testing, definitely. Continuous review, definitely. So there's some good things about it. Again, trying to convince your manager that 2 of us working together at the same pay rate is actually better than having us work separately and integrating it later is a fun discussion. Because they look at that and say, why am I paying for 2 of you? Why can't one of you do the programming? Aren't you people programmers? What's the deal here? Another interesting discussion you can have with people about the benefits of that versus not doing it. Anyway, does this work? Kind of. Any method you pick, by the way, so there's nothing about extreme programming particularly, but every agile method has its costs and benefits, okay? Nothing's actually perfect yet. We're not quite there yet. Anyway, but as I said, it is code-centered, which is slightly problematic in some respects. You don't get the design documentation you get in a conventional method. But you can fix that in the comments, right? Lack of a quality plan, that's probably true too. Because again, it's very code-centered. They're saying, well, it works. The build passes. I get green bar. It's great. It works. And because the tests reflect the requirements, therefore the product must be a quality product. So it's not exactly a direct connection, though, perhaps. What else? Yeah, it's not about how you go and do something. So the things I've been talking to you about are things that I know work in practice, which you often don't get in you don't get in those books or manuals about how to do extreme programming. I know because I've got those books. They talk about courage. Another thing that they talk about, which is kind of depressing, is that somewhere it's been quoted that the developers of XP said something along the lines of, it's not for everybody, really. It's really for the best programmers. Hope that's you guys. So what they've just done is they've consigned 49.9999% of the programmers in the marketplace can't do it. That's useless. As a method of building software, that's useless. Because naturally the best people will do the best job because they're the best. They will rise above any stupid method to build a product. It's independent of them almost, okay? What you actually want, a good method, is one that anybody could use. Even if you weren't the best programmer in the world, if you use the method, you still build good software. That's the hallmark of a good method, as far as I'm concerned. So for someone to say it's not for half the programming population, that's useless. Nonetheless, it has got some good things in it, okay, which you're going to try out. But yeah, I just find it interesting that they thought it wasn't for everybody. That what would be the point of the method then? If it's not for everybody, it's not a good method. Anyway, enough of a rant about that. What else? Uh-oh, that's not a good sign. That's the sign of death of PowerPoint, I think. Yeah. Oh no, it hasn't said it's. Oh, it is not responding. Yeah, now it's not responding. Great. Yeah, hang on, I'm just going to force quit PowerPoint. Wait a sec. Let me just do this while it can. Lunk. I love how that's just continuing on. I'm going to